Hello algebra students, this is section 7.5, solve applications with rational equations. Please put your name and date on your notes. By the end of this section, you will be able to solve proportions, solve similar figure applications, solve direct variation problems, and solve inverse variation problems. Let's start with solving proportions. We're going to use the cross products to be able to do this. All right, so in A we have 8y, and in the yellow or the orange highlighter we have 3 parentheses y plus 55. Now we're going to distribute here. So 8y is equal to 3y plus 165. Let's subtract 3y from both sides, so that we get 5y equals 165. Divide both sides by 5. Y equals 33. You could check that by putting y back into the problem. Now I would like you to do B in your groups on the whiteboards. In your groups, you should have gotten z equals 14. If triangle AB is similar to triangle XYZ, sometimes written as, this translates into triangle ABC is similar to triangle XYZ, then their corresponding angle measures are equal and their corresponding sides have the same ratio. Let's look at what that means. Angle A equals the measure of angle X, so those angles are equal. The measure of angle B is equal to the measure of angle Y. And the measure of angle C is equal to the measure of angle Z. Their sides are also proportional. So side A is proportional to side X, which equals the proportion side B is proportional to side Y. And C is proportional to side Z. Let's apply that in this example. On the map, Seattle, Portland, and Boise form a triangle. The distance between the cities is measured in inches. The figure below represents the triangle formed by the cities on the map. The actual distance from Seattle to Boise is 400 miles. My nephew actually made that. Oh, actually, no, he went from Portland to Boise over the summer. So you're going to find that actual distance in part A. So 4 inches is equal to 4 miles. Or, I'm sorry, 4 inches is equal to 400 miles. So then from Seattle to Portland is 1.5 inches. And we want to know the actual distance. So we set up a proportion like this. Now we're going to do the cross products. So 4 times x is 4x, and 1.5 times 400 is 600, because half of 400 is 200. You add them together. Now we're going to divide both sides by 4 to solve for x. X equals, 4 goes into 60 15 times, add a 0, 150 miles. Go ahead and get up and go to the boards and do B, the trip that my nephew made over the summer, which is Portland to Boise. So in your groups, maybe you set up a proportion or maybe you noticed a relationship here. But from Portland to Boise was 350 miles. This next example is something you might see on a standardized test because this kind of problem comes up a lot. A pine tree casts a shadow of 80 feet next to a 30-foot tall building which casts a 40-foot shadow. How tall is the pine tree? Let's draw a picture. Here's the tree, and it has an 80-foot shadow. Here's the building. And it has a 40-foot shadow. I did not draw this to scale, but the building is 30 feet tall, so how tall is the tree? Sometimes, and we won't see this yet, but when you take geometry, you will see that this relationship makes a right triangle. All right, let's set up a proportion. Some of you might not need to set up a proportion, but just for the practice. We're going to have the height of the object versus the length of the shadow in our proportion. The height of the building is 30 feet. The shadow of the building is 40 feet, and we want to make sure that building goes next to building. Then we don't know the height of the tree, but the shadow of the tree is 80 feet. So I put that in the shadow column. Now I want to figure out what x is. So maybe you can see this, or maybe you need to do the cross products. I always like to do the cross products. It's just easier for me. So 40x, I'm going to do this multiplication in my head because 8 times 3 is 24, and just add 2 zeros. Now we're going to divide by 40. We can cancel out a 0. 4 goes into 24 6 times, so x equals 60 feet. And that makes sense because the tree is double the height of the building, and its shadow was double the length. When you're ready, turn your page. Let's talk about variations. Let k be the variation constant, and that's just normal that we talk about k as the variation constant, or the proportionality constant. And it cannot be 0. Direct variation says that if y varies directly as x, or y is directly proportional to x, then y equals kx. If you are given that y is proportional to x, then it is understood to mean that y is directly proportional to x. In an inverse variation, if y varies inversely as x, or y is inversely proportional to x, then y equals k over x. It will make more sense in this example. The number of calories C burned varies directly with the amount of time spent exercising. Arnold burned 312 calories in 65 minutes exercising. Write the equation that relates C and T. So the first thing that we do is we just remember what was the formula for direct variation. Y equals kx. Then we'll just substitute the variables C and T. So calories burned is equal to the proportionality constant times the time spent. Then we solve for the constant of variation. The way that we do that is we put in the numbers they gave us. So 312 calories is equal to the proportionality constant times 65 for the time. Then we divide both sides by 65, and that does not go in evenly, so I'm going to use my calculator. K is equal to 4.8. Then we'll write the equation that relates the variables using the constant of variation. So we go back and we use C equals 4.8 T. Now in your groups, I want you to figure out part B. How many calories would be burned if he exercises for 90 minutes? Okay, so in your groups, you should have gotten C equals 4.8 times 90, which if you use a calculator or you did it by hand, it's 432 calories. Let's look at an inverse variation. The number of hours it takes for ice to melt varies inversely, that's important, with the air temperature. Suppose a block of ice melts in 2 hours when the temperature is 65 degrees Celsius. Write the equation of variation. So remember that the inverse formula is y equals k over x. Then we can change that into, well, what are our variables? We have hours and temperature. And we don't want to use time and temperature because that would be confusing. So we could use hours in Celsius. All right, so the number of hours is equal to whatever the constant of proportionality is over the degrees Celsius. Now we can solve for our constant of proportionality by putting in the numbers they gave us. So they gave us 2 hours and 65 degrees. The 2 hours is going to go into H. We're trying to solve for K. And the 65 degrees Celsius goes into C. If we multiply both sides by 65, we get 130 is equal to our constant of proportionality. Then we want to go back and put in K into our new equation. So hours is equal to 130 over Celsius. In your groups, I want you to solve for B, which is asking how many hours would it take for the same block of ice to melt if the temperature was 78 degrees. Do that in your groups. So in your groups, you should have gotten, when you divided these, that the hours is equal to 1.667, or it's repeating, right? The 6 is repeating, hours. And that makes sense because the temperature is warmer. It's 78 degrees versus 65 degrees. So it's going to take less time for the ice to melt. Before you put your notes away, please write a summary and then get your homework paper started by putting the heading of what your homework problems are.